I've been thinking lately, how much is my car actually talking to AI right now? It feels like it's more than just a fancy feature these days.
Oh, absolutely. It's this sort of unseen intelligence that's making your drive smarter, safer,
Yeah.
maybe even a bit more well-personalized.
Exactly. And that's what we want to dig into today. The incredible rise of AI in cars, specifically focusing on this thing called Edge AI.
That's the plan.
Yeah.
We're here to, pull back the curtain a bit, show you where the AI brains of your car actually live. Is it all happening up in the cloud?
Or is it right there in the vehicle, at
Yeah.
the edge?
Right. Or, as is often the case, some kind of smart combination of the two. We're going to unpack the, frankly, critical decisions automakers are making right now.
And what that means for us, for the driver,
Yeah.
for your experience, your safety, even your data privacy.
Precisely.
So if you've ever wondered why all these digital features are suddenly such a big deal in new cars, or maybe you felt that tech tug of war happening behind the dashboard, well, this is your shortcut.
Mm.
So why is this happening now? It feels like AI is really reshaping the car into a digital powerhouse. And it
Yeah.
seems like it's becoming a key way car brands stand out.
It absolutely is. It's
Mm.
not just about the engine anymore, is it? The why now is key. There was a recent McKinsey consumer survey just from 2024,
Yeah.
and it found something pretty startling. In Germany, 38% of premium car owners said they'd actually consider switching brands just for a better digital experience.
38%. Wow.
Yeah. And get this, back in 2015, that number was only 15%.
That's a huge leap in less than a decade.
It is. And even looking back, 13% still said digital features were a big factor in why they bought the car they did.
Okay, let's unpack that. 38%. That's not just some niche trend. That's like a fundamental shift.
Exactly.
It means for a big chunk of buyers, the digital side is now right up there with performance or the badge on the hood. It's become a real make or break factor.
You've hit the nail on the head. For the automakers, the OEMs, this isn't just about, cool gadgets anymore. It's hitting their bottom line, their competitive edge.
Right.
So they have this tricky balancing act. They need responsiveness, low latency, but they also have to worry about privacy and, of course, the cost of making it all work. It's a real tightrope walk.
So it sounds like the core issue is where the AI actually does its thinking, its processing. We train these huge models in data centers, sure, but the inference, the part where it actually uses the model,
Yeah.
that's where the big choice comes in.
That's the crucial point.
Yeah.
When we talk about running the AI, there are basically three flavors. You've got cloud-based, where the models run remotely,
Okay.
then edge AI, where the models run right there in the vehicle,
Yeah.
onboard execution,
Got it.
and then hybrid, which, as the name suggests, is a mix of both.
Right.
And what's really fascinating and kind of enabling all this now is how hardware is getting better, and we're developing these lightweight models.
Yeah.
It's making powerful, fast processing in the car at the edge way more possible than it used to be.
And these improvements, they're really changing things for us, the drivers. So where are we seeing AI making the biggest impact day to day in terms of safety or convenience?
Well, let's look at safety and assistance first. That's AD, Advanced Driver Assistance Systems and Autonomous Driving. AI is what perceives the world around the car, plans what to do, and actually controls the vehicle.
Okay.
And there's this really interesting development called end-to-end ADAS. Instead of lots of separate rules, it's offered a single, big, deep learning model, handling everything from the sensor data right through to the driving action.
Wow, so it's like one brain doing the whole job.
In a sense, yes. It's a big shift from the older systems. And of course, there's also in-cabin safety things like monitoring if the driver's getting drowsy.
Right, the safety stuff is critical.
Yeah.
But I think for many people, the first place they really notice AI is probably in the infotainment and comfort features, right? The bells and whistles.
Definitely. That's where you see things like natural language voice assistants that, actually understand what you're saying most of the time.
Huh? Yes, most of the time.
Right. And gesture recognition, personalized profiles that learn your music or climate preferences, even suggesting a detour for coffee based on your usual routes. It's about making the car feel more like your space.
That's the stuff that makes it feel smart. But you're saying AI goes deeper into the actual mechanics, too.
Oh, absolutely. It's playing a huge role in performance and maintenance. For electric vehicles, think better range calculation, smarter energy use,
Oh, okay.
or fine-tuning the braking, the traction control, adaptive suspension for a smoother or safer ride, and predictive maintenance. That's a big one.
So the car tells you before something breaks.
Exactly. Imagine your car flagging a potential issue and maybe even helping you schedule the service. That's peace of mind. And it even helps manage connectivity, making sure the car's network is healthy and secure, kind of like its own little IT department.
This is where it gets really interesting for me, because these aren't just lab experiments. They're features that are already changing how we drive every day, making things smoother, more intuitive.
And for a lot of these applications, especially early on, the cloud was the go-to solution. Many current systems, like those voice assistants we mentioned, often use cloud or hybrid methods.
How does that work typically? Like for voice?
Well, your voice command, the audio, might get sent up to the cloud. A big, powerful, large language model, an LLM, figures out what you meant and then sends the response back down to the car.
And that's where the hybrid idea comes in handy, right? Splitting the difference.
Precisely. Simple stuff, maybe turn up the heat, could be handled entirely onboard, edge processing, quick, no delay.
Okay.
But if you ask something complex, like, find me the best rated Italian restaurant near my destination that's open now, that query probably goes to the cloud to access those really powerful AI models and real-time data.
So hybrid gives you some offline basics, uses less data, but still lets you tap into the big cloud brains when needed, like ChatGPT, but for your car.
Exactly.
Yeah.
It's a clever compromise. But relying heavily on the cloud does bring challenges. That McKinsey survey we mentioned, it asked industry folks about the hurdles.
And what did they say?
Well, number one was network dependency. You need solid 4G or 5G, and let's be honest, that's not everywhere. Especially not if you're driving in remote areas.
True.
And nearly 40% said offline availability was critical, especially for safety systems like ADS or for premium car buyers who just expect things to work.
Okay, what else?
Latency, that delay. Cloud round trips can take 1,000, even up to 2,200 milliseconds, over 2 seconds.
Whoa. That's not great if the car needs to react quickly.
Definitely not. Reducing latency was key for 35% of those surveyed. Then you have data privacy and security. About 20% are worried about sending personal driving data up to the cloud.
Understandable.
And finally, though fewer mentioned it, about 6% flag the cost of all that data traffic, which the car maker usually has to cover.
So the cloud offers power, but the connection, the delay, the privacy, the cost, those are pretty big drawbacks, especially for core vehicle functions. That really highlights the tug-of-war you mentioned.
It does.
Which naturally leads us back to the edge. If the cloud has these issues, moving the processing into the car seems like the obvious solution.
Right. It directly tackles those problems. No network needed for core functions, better privacy since data stays local, lower data costs, and crucially, lower latency. We're talking potentially 300 to 700 milliseconds for edge processing.
Much better. A noticeable difference.
A huge difference in critical situations. And this isn't just an automotive trend, you know. Edge AI is popping up everywhere.
Like where else?
Industrial settings for predictive maintenance on factory machines, healthcare, in wearable devices doing real-time analysis, even smart homes for faster voice or gesture commands. The benefits are clear across the board.
Okay, so Edge AI sounds great, but it can't be that simple, surely. There must be challenges with putting all that computing power inside a car.
Oh, absolutely. Our research dug into those hurdles too. The biggest one, mentioned by nearly half, 36%, is resource constraints.
Meaning the chips in the car just aren't as powerful as data centers?
Exactly. Less raw compute power, limited memory, both flash and RAM, and less bandwidth to move data around compared to a server farm.
Makes sense. What else?
Energy consumption was a big one for 35%. Running intense AI calculations uses a lot of power, and that's a major concern for battery electric vehicles, where every bit of energy impacts range.
Yeah, the range anxiety factor.
Definitely. Then there's the challenge of software updates. AI models aren't static. They need continuous updates and improvements. Pushing potentially large model updates over the air reliably is tricky, noted by 15%.
Okay.
And a smaller group, 4%, mentioned the fragmented software landscape. Lots of different tools and frameworks for AI that don't always play nice together, making development complex.
So the big question then is, how do you squeeze these powerful AI models into the car's limited environment and make them run efficiently? It's not just making AI, it's making small, efficient AI.
That's $1 million question, or maybe $1 billion now.
Probably. And that leads us to how the models themselves are changing, right? Making them smaller.
Precisely. We need models that can actually fit and run well on the car's hardware. Those huge LLMs with hundreds of billions of parameters. Yeah, they're staying in the cloud for now.
But we're getting better at shrinking them.
Massively better. There's been huge progress in lightweight models, using clever techniques, like pruning, sort of trimming the fat off the model, and simplification. We can significantly cut down the size, often with surprisingly little impact on performance.
So, like, simple voice commands might run locally on the edge.
Exactly. Text-to-speech, speech-to-text, those often run on edge now. But something really complex, like generating video from a text prompt, that still needs the cloud's muscle.
Gotcha. And supporting all this requires a whole stack of technology in the car, right? Software and hardware working together.
Absolutely. You've got the software layer operating systems, some real-time for critical stuff like ADS, others for infotainment, then AI frameworks, the models themselves, tools to manage their life cycle, and under that, the hardware layer.
Which includes memory.
Right? Flash storage, fast RAM, sometimes specialized high bandwidth memory, and crucially, the processors.
Okay, let's talk processors. You mentioned the system on chip, the SoC. What are the key parts doing the work inside that chip?
Typically, you find four main building blocks. The CPU, the central processing unit, handles general control tasks. The DSP, digital signal processor, is good for processing sensor data streams. The GPU, graphics processing unit, does parallel calculations great for graphics, but also used for some AI tasks.
But the really exciting one for AI is the NPU, the neural processing unit.
That's the star player for AI. NPUs are specifically designed, purpose-built for the kinds of math involved in neural networks. They offer way more compute power for AI tasks, and crucially, they're more energy efficient than using a general-purpose GPU for the same job.
So we'll be seeing more NPUs in cars.
Definitely. The demand is growing fast, especially for handling newer, more complex AI models. GPU use for AI in cars will likely grow less dramatically. And interestingly, those DSPs, their role might even shrink a bit as end-to-end ADS models start handling sensor fusion directly.
So, boiling all that chip talk down, what does it mean for my drive? Faster reactions, better voice recognition.
Pretty much. It means a car that can process information and react potentially milliseconds faster, understand your commands more reliably, even with background noise, handle complex sensor data in real time, all while hopefully using less power.
And for the car makers, how do they manage this increasing complexity?
Two key concepts here are scalable chip architectures and heterogeneous integration. Scalable architectures mean modular designs. Think building blocks. OEMs can add more processing power or memory for higher-end models without redesigning everything.
Okay, flexible. And heterogeneous integration. Sounds complicated.
It's like advanced chip Legos. Instead of one giant monolithic chip, you combine smaller, specialized chips called chiplets together on a single package. So you might have a CPU chiplet, an NPU chiplet, memory chiplets, all optimized for their specific job, but working together seamlessly. It allows for amazing performance scaling and flexibility.
Right, so you can mix and match the best bits.
Exactly. And for NPUs, manufacturers might integrate them right onto the main sauce or offer them as separate chips, separate building blocks. Some newer companies are focusing on these standalone NPUs.
Pros and cons to that.
For the OEM, using separate NPUs can mean more scalability across different car models, maybe faster time to market, lower upfront design costs. But the downside is, well, it adds complexity to integrate everything together.
And we shouldn't forget the workhorses, right? The microcontrollers, MCUs.
Absolutely not. They are the unsung heroes. They run countless things in the car, often real-time tasks. And even NCUs are getting smarter, becoming capable of running some lightweight edge AI functions very efficiently and cost-effectively.
So with all these advancements in chips and software, the market must be growing pretty fast.
Oh, significantly. Our analysis points to the market for these advanced microcomponents in automotive, the really sophisticated chips growing around 24% annually.
Wow, 24% a year.
Yeah, projected to hit something like $18 billion by 2030. And the biggest drivers are ADAS autonomous driving and infotainment.
But even with all this tech, deciding whether a specific function should run on the edge or in the cloud, it's still a complex choice for the engineers.
Incredibly complex. It's not a one-size-fits-all decision. For each AI application, they have to weigh up performance needs, speed, latency, scalability against operational factors like reliability, security, how easy it is to maintain, and of course the cost, hardware cost, operating cost, how quickly they can get it to market.
So because of all those trade-offs.
Exactly. Hybrid approaches are really likely to be the dominant strategy for vehicle AI platforms for the foreseeable future. You get the best of both worlds, tailored to the specific task.
But making hybrid work smoothly requires changes across the whole industry, doesn't it?
It really does. It's transforming the value chain. OEMs need to move towards centralized EE architectures. Think of it as the car's central nervous system and really nail over-the-air updates. They need robust middleware, the software glue that holds it all together.
And the Tier 1 suppliers, the ones making the components.
They're under pressure. They have to seriously boost their AI skills and become experts at integrating these complex systems. And The semiconductor companies, the chip makers, they're shifting from just selling chips to providing more complete solutions, including software.
We're seeing lots of acquisitions because of that, right? Chip companies buying software or AI firms.
Absolutely. You see NXP buying parts of T-Take Auto and Kinara, Renesas buying Reality AI, Qualcomm buying Arriver. They're all building up these vertically integrated platforms. Plus, you have new players entering the market, often focusing specifically on those powerful NPUs.
So if you connect all those dots, what's the ultimate takeaway?
Collaboration. Simple as that. No single company can do this alone. Success absolutely depends on close co-development between the automakers, the Tier 1 suppliers, and the semiconductor players. They have to work together on safety, security, energy efficiency.
And aligning with industry standards.
Crucial. Things like UCIe. That's the standard for connecting chiplets and supporting big research efforts like IMEC. The future of car AI is definitely a team sport, not a solo race.
What an incredible journey today. We've really unpacked this sophisticated balancing act happening inside our cars: power, speed, privacy, cost. It's clear that making these intelligent vehicles a reality demands constant innovation and, like you said, real collaboration.
It really does. And looking ahead as AI keeps evolving, especially these lightweight models and specialized chips like MPUs, it leaves you with a fascinating thought, doesn't it?
Which are
With that line between what your car processes on board at the edge and what gets handled in the cloud, will it eventually become almost invisible to you, the driver, a seamless blend? Or will certain functions, especially the absolutely critical safety ones, always demand that instant onboard edge processing, forcing this constant innovation in hybrid systems to get the balance just right?
A dynamic future for sure.
Absolutely. A future where your car is genuinely learning and adapting right there with you on the road.